In recent days, the Indian Navy has finally unveiled a glimpse of its future maritime ambitions, the official concept design of its next-generation P-18 class guided missile destroyer. Indian media have enthusiastically proclaimed that this colossal vessel, with a full load displacement of 13,000 tons, will be equipped with an astonishing total of 144 vertical launch units. On the surface, these cold, hard numbers indeed outshine the 112 units of China's current 055 class destroyer. India has even boldly announced plans to build 10 such vessels. For a time, claims of surpassing the 055 and Asia's strongest were widely circulated. However, when we peel back the layers of propaganda, what is the true combat capability of this P-18 class destroyer, which embodies India's great power Navy dream? Can it challenge the 055 class benchmark status in the contemporary destroyer arena? To understand the P-18's positioning, we must trace the arduous and tortuous development path of India's main battleships. During the Cold War, relying on its close ties with the Soviet Union, India acquired 5 Kashan-class destroyers, which were once a formidable presence in the Indian Ocean. In the 1990s, India developed the indigenous Delhi-class destroyer based on Soviet modern-class destroyer technology. At the same time, the Chinese Navy was also struggling to enhance its regional air defense capabilities, gradually advancing through the 052B, 052C, and even 051C class destroyers. By the 2010s, the navies of China and India had taken divergent development paths. China, leveraging its accumulated industrial and technological strength, introduced the mature and reliable 052D class destroyer. In contrast, India's naval development has remained constrained by its reliance on imported technologies and the challenges of domestic production. During the same period, India introduced the P-17, a Kolkata class destroyer. Its core combat capabilities rely on imported Israeli technology. The main mast is equipped with 4 M2248 F-star active phased array radars. This configuration is similar to that of some European frigates. However, in terms of radar array size, power aperture product, detection range, and multi-target tracking capability, this medium-sized radar cannot compete with the design of Chinese and American mainstay destroyers, which integrate large, phased array radars around the bridge. The firepower core of the Kolkata class is a 48-cell vertical launch system, primarily launching Israeli Barak 8 air defense missiles, with a maximum range of approximately 70 kilometers, resulting in a clear ceiling on its area air defense capabilities. The improved P-17B Vishakhapatnam class developed subsequently, though slightly increased in displacement, retains the radar and weapon systems of its predecessor, with limited enhancement of core combat capabilities. In 2017, China's Type 055 destroyer made its debut, redefining the standards for 21st-century destroyers with its massive 13,000-ton displacement, 112 large-caliber vertical launch cells, the largest in the world, highly integrated radio frequency systems, and dual-band radar. Its emergence was like a pebble dropped into a lake, sparking a global wave of naval powers developing new-generation large destroyers. The US DDG-X, the UK Type 83, and even Japan's ASEV all push displacement and firepower to new heights. As a self-proclaimed major power, India naturally did not want to lag behind, leading to the emergence of the P-18 destroyer program. The conceptual design of the P-18, unveiled in July 2025, vividly illustrates India's ambitions. With a displacement of 13,000 tons, it matches the 055 and UK Type 83 in terms of size. However, what truly catches the eye is its extravagant configuration of a total of 144 vertical launch units fore and aft, far exceeding the 055's 112 units. How can more VLS cells be packed into the same displacement? The secret is not Shiva's divine intervention, but rather a key constraint: the size of the VLS cells. It is highly likely that the P-18 will adopt the vertical launch system from its predecessor, the P-17B. This system was specifically designed for launching the relatively small Barak 8 missiles. It is precisely this compact vertical launch unit that makes it possible to densely arrange 144 units on a 13,000-ton hull. However, this is precisely the greatest paradox and potential danger. In the P-18's firepower configuration, its VLS units are almost exclusively compatible with the Barak 8 and its subsequent improved variants. Even in its extended range variant, the Barak 8's range and firepower are significantly inferior to the HHQ-9B C missiles with a range exceeding 400 kilometers and the YJ-21 hypersonic anti-ship ballistic missiles, with a range exceeding 1,000 kilometers, which are compatible with the 055's VLS system. If the 144 cells, can only launch medium-range air defense missiles. Their actual area air defense and long-range anti-ship, land attack capabilities would be inferior to those of VLS systems with fewer cells, but capable of launching long-range, ultra-long-range, and hypersonic weapons. Even more concerning is its detection capability. The P18 concept diagram shows that it has abandoned the mast-mounted radar arrangement of the P17 series, instead adopting the mainstream layout of installing 4-phased array radars around the bridge. This is an improvement, however, based on the ratio of the array in the concept diagram. The radar size is likely still in the medium category. Whether its core performance metrics, such as detection range, multi-target tracking capability, and anti-jamming capability, can match those of the massive S+X dual-band radar system on the Type 055 or the Spy-6 radar on the U.S. Arleigh Burke II-class destroyers remains a significant question mark. Setting aside the paper specifications, the P18 faces its most severe challenge in the form of the inherent weaknesses of India's defense industrial system, time and execution capability. As of July 2025, the P18 remains at the stage of conceptual design. Referring to India's history of large-scale shipbuilding, the Vikrant aircraft carrier took nearly 20 years from groundbreaking to commissioning. The indigenous nuclear submarine Rahant project spanned over a decade from initiation to service. Even the smaller P17A-class destroyers had construction cycles far exceeding international averages. As India's first attempt at a technologically complex 10,000-ton destroyer, every stage of the P18's development from design finalization, domestic production or procurement negotiations for critical equipment, to enhancing shipyard construction capabilities, could become a time-consuming black hole. When will the first keel be laid? When will it be launched? When will it achieve combat readiness? These remain highly uncertain questions. Meanwhile, the global naval competition has not ceased. The US DDG-X, the UK's Type 83, and Japan's ASEV are also in the design or early development stages. China, however, has never stopped technological iteration, building on the solid foundation of the first batch of 8 Type 055 destroyers already in service, with multiple vessels from subsequent batches currently under construction, outfitting, or undergoing sea trials. Based on information from multiple sources, an upgraded 055B variant with comprehensive performance enhancements is likely already in development, potentially incorporating cutting-edge technologies such as all-electric propulsion, more advanced integrated radio frequency systems, more powerful hypersonic weapons, and even laser defense systems. Therefore, when the conceptual design of India's P18 drew attention and sparked heated discussions about surpassing the 055, a more intriguing question emerged. Will the P18, which remains on the drawing board, be the first to cut through the waves? Or will China's 055B, which incorporates the combat experience and technological advancements of the first 8 055-class destroyers, make its debut on the open seas sooner? This silent competition tests far more than just the dazzling paper specifications. It is an ultimate showdown of a nation's overall industrial strength, scientific research and development efficiency, and the resilience of its shipbuilding system. The release of the conceptual design for India's P18 destroyer demonstrates its strong desire to join the ranks of the world's top naval powers. The figure of 144 vertical launch cells certainly creates a significant visual impact. However, the combat capability of modern destroyers is the result of complex systems engineering, not a simple comparison of cell numbers. Constrained by the inherent limitations of its VLS system, the uncertainty of its radar system's actual capabilities, and India's concerning history of delays in large-scale complex military projects, the P18's journey from a dazzling PowerPoint presentation to a truly reliable ocean-going warship is bound to be a long and arduous one. While India is still enthusiastically touting the blueprint for its 10,000-ton destroyer, the Chinese Navy's Type 055 fleet is already patrolling the world's oceans, and the improved Type 055B variant may already be taking shape in the shipyard's secure workshops. The outcome of the warship competition will ultimately be determined by the pace of actual ship launches and commissioning, the development of integrated combat capabilities, and the technical maturity that withstands rigorous testing.